Now let's see the physical significance of moment of inertia. Okay, see, when we talk about moment of inertia, remember we are talking about the product of mass and the square of the distance, correct? So first thing on what the moment of inertia depends on is the mass, obviously. The second one is the mass distribution about the axis of rotation. Okay, see, two examples I'll give. So in this example, first thing is, see, look at the figure, we have two things, right? You have two wheels. So in the first wheel, the weight is distributed uniformly. Okay, so everywhere the weight is the same or the mass is the same. See, in the second figure, if you see, the rim part of that particular object, more mass is concentrated. See here, the total mass of the two objects is the same. Okay, let's say both of them weighs 50 kilos. Okay, so weight is, the mass is 50 kilos. Okay, now what changes is how the mass is distributed about the axis. For this, these two given figures, whatever you are seeing, for the first one, the moment of inertia we can find out, because since the mass is uniformly distributed, and if you take different values of r, summing up all of them will get the moment of inertia. Okay, whereas for the second one, if you take, see here, the mass is concentrated more on the rim part, correct? So the distance from the axis of rotation is more. Since we are doing m into r square, so since we are doing r square, so the moment of inertia becomes quite large compared to that of first one. Okay, so here, now what physical significance we can actually get from this example? So if you think about that, this is what happens usually in all the vehicle wheels. Okay, like most of the mass is concentrated on the rim part. Okay, and then an axle is connected to that, and the wheel will rotate, right? So as the wheel is rotating, since moment of inertia is quite high, so what happens is, as the wheel starts rotating, then even if small amount of torque comes in the opposite direction also, it won't stop. It will keep on going. Alright, see, this is one of the reasons why that even, let's say you start moving an object, let's say a bicycle, you start, let's say you start pedaling and the vehicle starts moving, then even if you press a little bit of brake also, since the wheel is rotating, the moment of inertia will be quite high. So even then, the wheel will still be rotating. Okay, see, there are a lot of other factors also which plays here, but this also plays a very important part. Okay, so this is the reason, like this example, from this we can understand that if the outer part, that is with respect to the axis of rotation, if the mass is concentrated a little far from it, then the moment of inertia will be quite high, right? So this is one of the physical significance of moment of inertia. Okay, another one example is a flywheel. Okay, see, this is a flywheel. So flywheel also, it has the masses distributed in such a way that the moment of inertia will be quite high. Like once you start, you have to give a lot of force to make sure that flywheel rotates. Once it rotates, then it's easy that we can do a lot of practical examples from flywheel. And stopping a flywheel also requires a lot of force. Okay, so these are like two popular examples of physical example or significance of moment of inertia. Okay, so I want you guys to come up with different examples of your own and think of how moment of inertia can be applied.